right, this should be the last video for normal distribution. So right here is just going over again the z-score. You have the data value that you've got, in this case was 17, minus the mean, which was 5, divided by the standard deviation, which is 6. So 17 minus 5 over 6 gives you 12 over 6, which is 2. Means it's 2 standard deviations above the mean, where the standard deviation is 6. Okay, so they did 5 plus 2 times 6 gives you the 17. Right? If x equals 1, did it in this way, you get negative 0.67. It means that it is 0.67 standard deviations below or to the left of the mean. Okay, so when z is positive, it's above. When z is negative, it's to the left. Some doctors believe that a person can lose 5 pounds on the average in a month by reducing his or her fat intake and by exercising consistently. Suppose weight loss has a normal distribution. Let x equal the amount of a weight lost in pounds by a person in a month. Use a standard deviation of 2 pounds. Okay, right here we've got the mean is 5 and the standard deviation is 2. So, suppose a person lost 10 pounds in a month. The z-score when x equals 10 is 2.5. That z-score tells you that x equals 10 is 2.5 standard deviations to the right of the mean, which is 5. Okay, so 5 plus 2.5 times 2 will give you 5 plus 5 is 10, because we're actually losing. Suppose a person gained 3 pounds. Now this would be a negative 3 because we're looking at weight loss. So then the z is negative 3 minus 2, minus 5 divided by 2. It's going to give you negative 8 over 2 or negative 4. So your z here is negative 4. That tells you that it is 4 standard deviations to the left of the mean. All right. Last one here. Suppose the random variables x and y have the following normal distributions. X is a normal distribution with a mean of 5 and a standard deviation of 6. And y is normal distribution with a 2 mean and a 1 standard deviation. If x equals 17, z equals 2. That's what we just did over here. Okay? So, if y equals 4, what is the z there? All right, well, you would use this one with the 4, and you're going to have 4 minus the mean, 2 over 1, 2 over 1, which is 2. So my z-score on that second one is also 2. So that's what you've got right here. Since x equals 17 and y equals 4 are each 2 standard deviations to the right of their means, they represent the same standardized weight gain relative to their means. That's what's meant by standardization. Okay, from 1984 to 1985, the mean height of 15 to 18-year-old males from Chile was 172.36 centimeters, and the standard deviation was 6.34 centimeters. Let y equal the height from 84 to 85. Then y equals this, 172.36 with a 6.34 standard deviation. The mean height from 2009 to 2010 was 170 with a standard deviation of 6.28. They're known to follow a normal distribution, so let x be the height from 2009 to 2010. Find the z-scores for x equals 160.58, in which case you would be doing this value That's going to be the 160.58. And y equals 162.85. You'll be using this one for 162.85. Okay, so we'll do the x first, I guess. The z-score equals 160.58 minus 170 over 6.28. The y-score here, so to get the z-score, the y one was 162.85 minus 172.36 over 6.34. So, let's see what we get here. 160.58 minus 170 divided by 6.28 gives me a negative 1.5. And this one, we get 162.85 minus 172.36 divided by 6.34. It is also negative 1.5. So, what can you say about these as they compare their respective means and standard deviations? They are both negative 1.5 standard deviations. Standard deviations from the mean. Okay, so they're on the left. And you've got they're down here. Okay. So, and it means really that relative, they're the same. Nobody has really changed much in the 30 years. Okay. So, turn in this problem, and you're going to do exactly what we just did. Find the z-scores, interpret each z-score, and what you can say about each of those. All right. Using the normal distribution, the shaded area in the following graph indicates the area to the left. It is represented by this probability where x is less than the data value. Normal tables, computers, and calculators calculate the probability of this. Okay, if you want this, you would have 1 minus this, just like we did at the beginning. Okay. This is a percentile. What is below that particular point? At the 90th percentile, it means 90% of the scores are below that. Some percentiles are so common they are named. Q1 is the 25th percentile. That's the first quartile. The median is the 50th percentile. Q3 is the third quartile, the 75th percentile. To find percentile, you will use a formula to find the area behind the z-line. So most of the time people use the table because you have the mean here and the z-score. And if you just have the percentile, you end up having two things that are unknown, so you really can't solve the problem. Here is a table for you to use. Right here, you've got a z-score on the 25th percentile of negative 0.675. And a z-score on the 75th percentile of a positive 0.675. 90th percentile, 1.282. Okay, a lot of people are interested in those. So you definitely want to be able to look at your table to find percentiles. The mean BMI for a 60-year-old man is 29 with a standard deviation of 6. Remember that we had your percentile equaling x, your mean, which I should use the other that we've been using, not that one. Ow. Okay. So, it'll be the mean plus the z-score times the standard deviation. So, 90th percentile will have the mean, 29, plus the z-score for a 90th percentile is 1.282. So you have 1.282. Did you remember that right? Yes. Okay. Times your standard deviation of 6. So 1.282 times 6 equals plus 29. So the 90th percentile is at 36.692. So what that means is 90% of the 60-year-old BMI for 60-year-olds is below that 36.692. Okay. What is the 75th percentile? Well, you still got the 29, still got the 6. The difference is that 75th percentile is 0.675. So you will have 0.675 times 6. 0.675 times 6 equals plus 29. So you've got 75th percentile is 33.05. That's where you've got your 75th percentile. Okay. So this is a little bit of review here. The golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a golfer scored between 66 and 70. All right, right here. The golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a golfer scored between 66 and 70. Well, the best thing you're going to do here is go to Desmos and I'm going to need to just get to Desmos by itself. All right. What you're going to put in here is the function, and we're going to need the normal distribution one. All right. Find the cumulative probability. Well, I found the z-scores of what we had, and they were negative 2/3, which I put in as my minimum, and a positive 2/3, which I put in my maximum. It tells me that the probability is 0.4950. It's between here and here. That is the easiest way to finding the probability under this curve. Okay? So, what I just showed you, doing the z-score on 66, you had 66 minus 68 divided by the standard deviation of 3 was negative 2/3, which I put in, and 70 minus 68 divided by 3 was a positive 2/3. So that's where I went from the negative 2/3 to a positive 2/3 to get my probability. You would put in 0.4950. The last problem down here is a problem for you to turn in. Calculate the first and third quartile scores for this exam and see if you can get the middle 50% of the exam scores. which would